Shields at maximum. Full reverse. Report. We're clear of the shockwave.
You've probably seen videos like this ones and are familiar with the idea of screen or camera shake. Shaking the camera isn't hard, but I want to talk about some things you can do to make shakes look better. The first question is, do we want to move or rotate the camera? The answer depends on the perspective of the game. With positional shake in 3D, due to perspective, objects closer to us shake more than the objects farther away. Also, in some games, camera can clip through geometry when you shake it. Rotation-based shakes don't have these problems, so in 3D they are the best option. But in 2D games, camera is usually orthographic, so the only meaningful rotation is roll. Roll-only shakes look a bit weird though. Luckily, none of the problems of positional shake in 3D apply to 2D, and we can use it without any drawbacks. To summarize, use pitch, yaw and roll for 3D and X, Y and roll for 2D. The other thing is the motion type. Some tutorials on camera shake suggest assigning a random position to the camera every frame, but it's a bad approach because of several reasons. Firstly, you have no control over frequency of the shake. Secondly, it lacks continuity. Snapping camera between random positions is fine for weak shakes, but for the stronger ones you need some sort of a smooth motion. Thirdly, it lacks predictability. The good shake should move kind of back and forth, imitating spring motion. Two random waypoints can easily land close to each other and completely ruin the effect. The last thing is time envelope. The shakes should not start and end abruptly, especially the stronger ones. They should have fade in and fade out. Also, people are a lot more sensitive to the differences between small shakes than to the differences between big ones. To account for this, strength of the shake should not fall with time linearly, but a square or even cube of time. What are your options for making cool shakes in Unity? There are plenty of tutorials on the subject with neat scripts that will do the job. But there is a much better built-in solution – Cinemachine Impulse System. It's very powerful and you can make all kinds of shakes with it. You can choose motion axis, layer noises and sine waves, make shake strength dependent on the distance from the camera and much more. But the impulse system has a fatal flaw. It wasn't written by me, so I made my own thing. I didn't want to pack all the options into a single class, so I wrote a system that works with an interface. It contains a property representing current local position and rotation of the camera. It has a type displacement, which is a struct that allows me to handle both position and rotation simultaneously. It has two vector3 fields, one for position and one for Euler angles. I use Euler angles instead of quaternions because by doing so, I don't need to deal with rotation composition. Instead, I can simply adapt Euler angles of two shakes. I can adapt displacements and multiply them by float. The struct also defines some functions analogous to vector3 like scale and lerp. Interface has a bool property that can tell us when we need to get rid of the shake. It also has two methods, initialize and update. The manager of shakes will call initialize when the shake starts and call update every frame, passing in delta time and position of the camera. As a quick example, here is a very simple shake class. It implements iCamera shake and sets position of the camera to a random point every frame for some time. The manager class camera shaker is a mono behavior. I made it a singleton so we can call the shake system anywhere from our code. It has a list of iCamera shakes, to which we can add a new element from outside the system. In the update method, it loops through the list, removes finished shakes and updates active ones, adding up their displacements. The resulting displacement is then assigned to the camera's position and rotation. The camera should be a child of another game object, so when we need to, say, follow the player around, we can move the parent while the camera shakes in local space. To add a new shake, we create an instance of some shake type and pass it into the shake method. Now let's look at some shake algorithms I implemented. The first one is supposed to imitate more natural looking vibrations. It's useful for things like explosions, big collisions, loud low frequency sounds. The idea is to get random but continuous positions and rotations from layers of Perlin noise with different frequencies. The noise value is then multiplied by the amplitude of the time envelope. The amplitude rises and falls linearly and has a flat sustained top. Its max value is between 0 and 1. Naturally, in this setup the stronger shakes last longer. And to make it look better, we square or cube the amplitude. The resulting displacement is then scaled by the strength of the shake in the given axis. The same happens for all 6 of them. Perlin noise works nicely for longer shakes, but often you want the shakes to be short and precise. For that occasion, shake based on noise is way too unreliable. Depending on the starting position in noise, shake can become much weaker than you intended and ruin the effect. In case like this, another algorithm helps. Unlike noise-based shake, it provides reliable level of strength. Let's see how it works. We randomly choose a direction and pick a point on a circle with the radius dependent on the strength of the shake. The camera moves to this point in specified amount of time. Then we choose another direction. We add a random vector to the vector opposite to the previous direction and normalize the result. When the random vector's length equals to 0, the camera will move back and forth along the line, and when it gets larger, the motion becomes more random. After we have chosen a new direction, we pick a point in that direction on a circle with the radius smaller than the first one, and the camera moves to this point. This continues for a specified amount of iterations, with the last radius 0. Algorithm is the same in 3 dimensions and for rotation. Another interesting thing you can do is to change the strength and direction of the shake depending on the position of the shake source relative to the camera. You can make it so the direction of the kickback gives a clue about the position of the explosion. Or you can decrease the strength of the shake depending on the distance to the camera from the source. In case you want to use my camera shake, source code and documentation are available by the link in the description. To conclude, I want to give some general advice for working with camera shake. First of all, have an option to disable it. Camera shake makes some people dizzy and some people just hate it. You can even add a slider for more options. The second tip is to mind the conditions in which you tune the shakes. The size of the screen has an important role, as well as the frame rate. It will feel very different on your phone screen in 30 fps than on your PC monitor in 60 fps. The final tip is the one you hear every time someone talks about camera shake. Do not overdo it. Shake is powerful but disrupting effect. Use it responsibly. If you have a shake as a response to some actions which happen often, the shake should become unnoticeable unless you deliberately try to spot it.